So some little misconceptions I want to cover with the quiz with this problem, and then just kind of wrapping up with the quarter. That quiz was our last grade on the quarter, so just things that you could still be doing at this point for this week would be if you did not finish your Delta Math Part 1 homework, get that done, turned in for late credit. Additionally, your Unit 4, if you wanted to retake that and get it done before the quarter ends, you have this week. I know some of you have been starting to work on that, so just keep that in mind. You could get that done before Thursday. We just really only have after school today and Wednesday, so if that's something you want to do, make sure you kind of communicate that to me, so I can get that a spot for you for the retake center. But if you are not ready to retake Unit 4, do not rush it, because you have until the end of Unit 6, which I think should be around the end of February sometime. So if you're still working on Unit 4 retake stuff, you have time. And if that grade on your retake is higher and it changes your quarter 2 grade by a letter grade, I'll just submit a grade change form for you. It's not a big deal. Remember, it just like when you get your report card, like, I don't know, within the next 2 weeks, it would obviously have changed from that. So just keep that in mind. I have no problem doing that for you because I don't want you to rush through. I'd rather you take your time and really learn through from your mistakes. So any other questions with that stuff? All right, so we have if x minus 4 is a factor of f of x, we want to find all the remaining factors. So I saw people do this and kind of think about a couple different ways, and some things I want to kind of go over from your quiz with that as well. So can anybody tell us what was one way you could do this? Saw lots of different ways. There are a lot of different ways you could kind of think about this. You could do synthetic division. So here was kind of like concept number 1 with synthetic division. If I'm given a factor and I'm setting up like my L that fell on the ground, what value should be out here if my factor was x minus 4? Yes, Devin, plus 4. So then I know I'd use my coefficients of 1, 3, negative 36, and 32 after. So a couple things from your quiz was, on your quiz you were given a solution. So you were basically given 4, and you're like, okay, is 4 a solution here? Is 4 a 0? Is 4 a root? Like one of those kind of vocabulary words. So you wanted to see that in the end using synthetic division. Some of you flipped the sign. Remember, you should only remember factor, flip. If you're given a factor, flip, but if not, you do that same value. So from here with synthetic division, remember you're always bringing down your 1 first, and then another thing that I saw some of you guys doing, just kind of getting confused between long and synthetic division, was some of you guys were subtracting between each time here. Remember with synthetic, it's multiplying and then adding each time. What was this? 8. And then you'd end up with a negative 8 here, negative 32, 0. So with here, we have 1, 7, and negative 8. What do 1, 7, negative 8, and 0 tell us? What do those values after synthetic tell us? What does maybe the 0 at the end tell us? There's no remainder, which check I needed to do that because I was a factor. So that's like a good check. What does 1, 7, and negative 8 tell us? What does 1, 7, and negative 8 tell us? Is that like a password code or something? What does 1, 7, negative 8 tell us from here? I know we know this. What does like 1 represent? Yeah, 1 represents that coefficient, and that would be 1x squared. Thinking about, I started off with x cubed, so just drop a degree by 1 if I was dividing by x minus 4, which is what I did here. to keep factoring. And then I'd have plus 7x and then a minus 8. So a lot of you guys got this far, but we want to factor all the way and factor completely. And can we keep factoring x squared plus 7x minus 8? Yeah, what do those factors become? What do those factors become after you keep factoring that? Yeah, we still have x minus 4. What about that quadratic? What would that factor into?
X plus 1 or x minus 1 and x plus 8.
Great.
X minus 1 and x plus 8.
There we go. So we have x minus 1 and x plus 8. That will multiply to negative 8 and add up to 7 for us. So we're going to keep building off of this today. And what we're going to get into is solving. But being able to kind of do this initial idea and step and get into those factors kind of definitely like phase 1 of solving. What questions do you guys have for the warm up? Alright. So we're going to get into solving polynomials today. So this is on our slides. No need to copy it down. But we're going to kind of, I think I'm going to come back to this at the end, and we're going to kind of go through our examples in like your phases and kind of like get into those different questions that we were going to ask as we're solving. It's going to be really similar to kind of what we did with quadratics, right? With quadratics, what did you always see if you could do first to help you solve? Well, with our quadratics, what did we always check for first? What did we always want to see if we could do first? What do you think, Leo? Yes, just factoring in general, right? So with your quadratic, you were always like, can I factor? And Leo's bringing up what we should check for first when factoring, right? Greatest common factor. So really similar to now once we're working with polynomials, we're always going to check for factoring first. So I'm going to give you guys, I don't know, 2 minutes. We have 2 functions up here, and I want you guys to factor both of them completely, and then we'll solve. We'll finish solving out together. So this is, all right, guys. So let's read back together. You should have kind of, maybe you're finishing up your factoring. So looking at your first question, we have 4 terms, and I saw everybody doing a great job factoring by grouping. And if you got this far, amazing. What should we notice if we got this far with the factoring? What can you still do, Leonard?
You can turn the x squared plus 16 to 6 plus 4x minus 4.
Awesome. Factoring that difference of squares. So here we have our function factored all the way. And this is where from now we're going to be able to solve. So just like when you had a quadratic, you factored your quadratic, and then how did you solve from there once your quadratic was factored all the way? What did you do with each of those factors? Set them to 0. So that is exactly our same process here when we are solving a polynomial. We're just going to have, with quadratics, we typically only had 2 factors. Now we're going to have just more than 2 maybe. Or maybe one of our factors might end up being a quadratic. But we'll have to just kind of look at each scenario differently. So we're going to do the same idea of setting each factor equal to 0. So think about why that makes sense, right? Equal to 0. F of x meaning y equals to 0. Where graphically is your y value 0? Your x-axis. So this is you finding those solutions, those roots, those x-intercepts, right? That's what your y value is 0. That's on your x-axis. So we're going to do exactly what Elijah told us. We're going to set each factor. So I'm going to have x plus 4, set that equal to 0. Of x minus 4, set that equal to 0. And I'll have x plus 2, set that equal to 0 as well. So this is us now seeing we're going to end up having 3 solutions. Why does it make sense that I know I should have 3 solutions? Amazing. My degree from the beginning was 3, so that told me you have to have 3 solutions. And what are my 3 solutions? X equals, what's my first value? -4, what's my second value? Second value for x would be 4, and then lastly we'll have -2. So those are my 3 solutions, or my 3, these are all real roots or real solutions. These are my 3 x-intercepts right there. So similar to your quadratic work, just now an extra factor. What questions do you guys have here? So our second example, you guys factored out your GCF first, and then noticing that it was the difference of cubes, so using that like SOAP idea. So you have 3x for your GCF, and then x minus 3, and then x squared plus 3x plus 9 if you factored all the way. We're going to do that same idea, right? We're going to set each factor equal to what? 0. So let's set each factor equal to 0 to help us keep solving. So my first factor would be 3x. So I'd have 3x equals 0. So what would x be equal to here if I have 3x equals 0? 0. So we know x equals 0 is one solution. And then we also had x minus 3. Let's set that equal to 0 as well. So my second solution, and I know, would be x would equal 3. So let's check in from our original. What was our degree? 4. I need to have 4 solutions. So far I have 2 solutions. And what are those 2 solutions? They're 2 real solutions. So I still have 2 more that I'm missing. And that's going to come from this quadratic right here. This quadratic, right, degree of 2. So let's figure out about this quadratic. So go through your questions with this quadratic. Can you factor this? Does something multiply to 9 and add to 3? No. What do you do to solve a quadratic if you can't factor? Our favorite thing is the quadratic formula. I'll write it on the board in case you don't already have this memorized by heart at this point in the year. So you have your minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. So we know we're going to have to solve x squared plus 3x plus 9 using my quadratic formula. So I would have x equals -b, which means -3, plus or minus the square root of b squared. So 3 squared would give us 9, minus 4 times a, which is 1, times 9, which is c, and I'm all dividing that by 2 times a, which is just 2. So back to your quadratic work, think about underneath your square root. What's something you're noticing? What are you kind of noticing about the nature of these roots? Yes, Anna. So underneath your underneath your square root would become negative. So if that's negative, Anna, what else do you know? Great job. So those 2 missing solutions I had to get up to my 4 for my degree are imaginary. So I had 2 real, 2 imaginary. So what's gonna under here would become like -27, right? So think about, I have the square root of -27, and how would I simplify the square root of -27? Think about, is there a perfect square within 27? Yeah, what's that perfect square? 9, right? So you have like -9 and 3. And what happens if I take the square root of -9? That becomes, what was that even?
3i.
Great job. So this is really 3i root 3, how that simplifies. So x is going to equal -3 plus or minus 3i root 3. all divided by 2. So this becomes our 2 imaginary, circled in blue, and then my 2 real as well. So I have my degree of 4. So it's all kind of playing off of and building off of your work with your quadratics. And this would just be you finding your solutions after you factored completely. What questions do you guys have here? All right, so see how everything's kind of coming together so far from like what we've learned throughout the year, right? Kind of building off of all those works of quadratics. A lot of pieces are coming together today, so let's keep putting it all together. Why don't you guys take a moment and how much you're given and kind of thinking about what you notice here. All right, guys, so we're given that f of -3 equals 0. We want to find all of our other solutions. So kind of think about what we just did, right? Always look to see if you can factor first. I have 4 terms. If I was to factor by grouping, it's not going to end up working out, right? I have x squared and then like x plus 6, factor out -1. That x plus 6 and that x plus 30 aren't going to match up. So I'm not going to be able to factor. But I am given that f of -3 equals 0. What can I do with that to help me find other solutions? What could f of -3 help me do so I can find my other solutions? Kind of something we did a little bit in our warm-up this morning view. Think back. So we know f of -3 equals 0. So what could that tell us? What could that do to help us find all of our other solutions? What do you think, Laura? Yeah, so, well, it depends on what you're doing, right? Are you doing synthetic division or are you doing long division? If you're doing long division, you'd have to divide by that factor. So that factor would have been what? What would that factor have been there? If your solution ends up being -3. Yeah, that would have been the factor of x plus 3. So if you want to use long division, you divide by x plus 3. If you want to just do synthetic division, you would just use only -3. So if we just do synthetic division with just -3, and then we'll set up our synthetic division with our coefficients. So I know that'll be 1, 6, -1, and -30. So I have about x cubed, x squared, x, and then just my number. Now going through with synthetic division, just dropping down our 1 first. And then we'll get all the way back up here by doing what? How do I kind of get to that next term with synthetic division? Great job. Multiply by -3. And then I'm doing what with those two? Adding, and then we'll cycle through. So now multiplying, we'll get -9. Adding together, we'll get -10. Multiplying by -3, we'll get 30. And they added together to get 0, which tells me I'm on the right track, right? Why does that tell me I'm on the right track? Why does getting a remainder of 0 tell me I'm on the right track? Yeah, I had to have it be 0, right? Because it told me from the beginning that -3 was a solution. So I have to keep factoring completely to help me find all my other solutions. So build off what we did in the warm-up. What did 1, 3, and -10 tell us? What did 1, 3, and -10 tell us? Those are my coefficients, right? So 1 is my coefficient for what term? That's to start us off. X squared. So I'm going to have 1x squared plus 3x minus 10. And now I need to find the solutions from here, because that's kind of what's left over after I divided out that factor of x plus 3 with synthetic division. So finding those solutions here, right? It's a quadratic. Finding solutions, I know I need to make it equal to 0, and it's my good old quadratic. And now if I want to find the solutions here, what should I think about doing? What do you think, Laura?
Oh, I have a question. Why is it not like x to the third power plus 3x squared minus 10?
Because we started off with the x cubed. So then remember, you drop your degree by 1. So you divide by like a factor with a degree of 1. So you're dividing really by x plus 3. So you have your quadratic, right? Think about solving this quadratic. What's always your first question? Can we factor, right? Does something multiply to negative 10 and add to 3? Yeah, what is that? What multiplies to negative 10 and adds to 3? Great job. So now we've factored, and once again, how do I keep solving from here? I set my factors equal to 0. So I'm going to have x plus 5 equals 0, and x minus 2 equals 0. So we find in the end that x is going to equal negative 5 and 2. So let's think about my solutions, right? I have negative 5 and 2. Well, what was my original degree?
3.
3. What's my third solution I also need to state? Yes, negative 3. So I also knew from the beginning that x should also equal negative 3. So this was basically like, in this problem, was like, hey, you're given 1, find the others. But don't forget to kind of state that 1 in the end. All right, what questions do you guys have here? So we've done the scenarios of like from the beginning. So if you guys remember, like I said, there was like that Venn diagram. So here's your progressions in your questions with that Venn diagram. Kind of think about your first examples. First, you're just kind of starting off thinking like, can you factor? And if you can factor, great, factor and set your factors equal to 0 and solve. This is kind of your second progression of like, okay, shoot, I can't factor this polynomial, but I do know one solution, or I do know one factor. And if I know one solution or one factor, I can kind of divide out to find my remaining, because I'll usually be left with something much easier that I can factor, or I could solve using the quadratic formula. But now we're going to get into our third scenario. This is the kind of most kind of new information will be given today. And this is a scenario of how could we have done this problem if we didn't have that like starter 0, right? That starter 0 tells us kind of like how we can start the problem, that 0 to divide out. So to be like, how could we have solved this if we have no way to factor? And that is going to be using the oh so important rational root theorem. So if you see rational, like a rational number, people say that in math. What is like a rational number, like a fancy word for? The what? They are real numbers. Like if you say a rational number, that's a really fancy word for a fraction. So your rational root theorem, kind of think about that idea. It's going to be kind of like fractions. All fractions, all possible fractions that could be roots or solutions to a polynomial occur when you have like plus or minus p over q. So what in the world is p? What in the world is q? P is going to be your factors of the constant. So that means that last number at the end. That's your p. So looking at this example here, what's that p value we have? The last constant all the way at the end. What do you see, Leo? There you go. So p is negative 10. And q is your factor square of the leading coefficient. So always make sure you're in standard form. And your leading coefficient here is what? 3. So that's my coefficient with in front of my highest degree. Number P is that constant at the end. So basically, this is going to give us a list of numbers to start off with. In that last problem, you were basically given like, this is your 0, this is your solution to help you get started. Now how this situation's different is we're going to create a list, and we're going to kind of pick and choose from that list and try and figure out what could work. So this is going to give you your possible list of candidates that could be rational solutions. And it's going to come from our plus or minus P over Q. So to help us figure out, we're going to find all those factors for P and all those factors for Q. So I would start off with your P. So thinking about 10, right? What are factors of 10? So what times what gives us 10? What do we know? What times what gives us 10? 5 and 2, what else? Great job. So I always like to write it in like numerical kind of like order with kind of thinking about 1 and 10, 5 and 2, from what you guys said. That's our list, right? So I'm including plus or minus because I'm just going to do that to like kind of cover my scenarios, right? Because I could have a positive 1 and a negative 10. I could have a negative 1 and a positive 10. So that plus or minus just kind of covers both those scenarios. Now let's talk about 3. What times what is our factors for 3? Yeah, 1 and 3. So I can have plus or minus 1 and plus or minus 3. So, right, so I could have positive 1, positive 3, negative 1, negative 3. Those multiply together to give us 3. So, what is going to be our possible list? That is going to come from your P over Q. So, how I kind of think it's easy to keep things organized is take your P values and then you have to divide them by every single Q value you have. So we're going to take our P values and then we're going to divide it first by our Q value of 1. Well, what do I know? Anything divided by 1 will just give us back itself. So kind of my first list is just going to end up being those same values of P, right? Plus or minus 1, plus or minus 2, 5, and 10. Because all of those divided by 1 gave us back itself. Now I have all those same P values, but now I'm going to divide it by my next Q that I have, which is 3. So I'm going to have plus or minus 1 over 3, 2 over 3, and 5 over 3, and 10 over 3. And that is our whole list of possible rational real roots. So I do know this has a degree of 3. So with a degree of 3, I could have 3 real roots, or my other scenario could be 1 real and 2 imaginary. So either or of those scenarios, all my possible real roots that are rational roots are going to come from this list. So that's kind of like your starter list to help you then finish out the problems like we just did in that last example. What questions do you guys have about the theorem and creating this list? What do you have, Senna?
So is this the what is this supposed to
So remember our last problem? Yeah, like what's the purpose, right? Remember in the last problem, you were told like x equals negative 3 basically is the solution. So basically, we're now going to be able to do problems without like that starter solution to help. because with that last example, you couldn't have factored it. So you would have just like been sitting there looking at it and you're like, well, there's literally nothing I can do, right? I can't factor it. I don't know a solution. This gives you your list now to help you find which one is going to be a solution to help you get that started. Now it makes sense when we do our next example together. Are you ready to see it? Okay. So take a second, jot this problem down, and then kind of see something you maybe are noticing about this polynomial. Alright, so we have x cubed minus 4x squared plus 8. What's something you noticed about this polynomial if we want to find the solutions? We have a degree of 3. So how many solutions should I end up with if I'm finding all the solutions? 3. So what are our scenarios that my solution types could be? If I have 3 solutions, what are those scenario types for my solutions?
2 imaginary, 1 real, and 3 real.
Good. I could have 3 real. I could have 2 imaginary, 1 real. So I don't know what the solutions are at all going to be, right? That's the fun of the game. Let's solve it to figure it out. So go through your progression of your questions. Can we factor this? Can we factor this? No, right? There's 3 terms. And if it was 3 terms, I would kind of look to see like, okay, would this be the square of that? Nope. It's not going to work out. So I can't factor. Do I know a starter like solution to help me get going? No. So that's why, back to Sina's question, what's this theorem? What's the purpose of it? This is the purpose for this theorem. This is us finding those solutions. And we're going to find those solutions by making our P over Q list. So remember, out of this, what's my P value? What's our P value? It is 8. It's that constant at the end. What's our Q value? 1. And everybody, now let's make our list of P over Q. So just start thinking about what we have over here. You can kind of just jump to P over Q when your Q is 1, because it's going to be the same thing as just those P values, right? Because 1 times 1 is the only way you're ever going to get 1. So I know my factors for Q are just 1. So 1 divided by all those P values, it's just going to keep us the same P values. So what are those factors that we know for 8? Yes, 1, 2, 4, and 8. Now back to what's the deal? What's the purpose of this theorem? Like, why do we need to know it? What's it going to do for us? Here's what it's going to do for us now. Before we were told like, hey, 8 is a solution, go from there. Now I have my list of 16 possible candidates. One of these is going to work to be a solution. And this is where we're going to kind of work together as a team to kind of figure out what could be our solution. And how do we know if one of these would be a solution? What's something we could do to kind of figure out that? What do you think, Eamon? Amazing. If you plug your values in, you know it's a solution if you equal 0. So you guys are going to work together with people at your table, right? Like you do 1, you do -1, you do 2, you do -2. Kind of split up your numbers to see what you guys find. Will give you that, when you input that value, will be a solution, meaning you're looking for it to equal 0. So why don't you guys take a minute, split up those values, try and find it. Who found a solution that worked? Sam, what did you find? You found 2 worked? Okay, so what if you were someone who tried 4? So I think I've told you guys before about like how you can kind of copy and paste in your calculator. So imagine doing this on your test, right? If you had 16 that you were trying to work through, that would get pretty tedious and annoying. Like without having your like table to split it up with you. So remember, you can always copy and paste if you have your TI in front of you. Remember, if I wanted to try 2, this is my first time using this new one on my computer. You can kind of just arrow up, like right here. This is when I tried 4. So if I hit enter again, that goes back through, and then you can arrow through and replace all your 4s now with 2, and that'll make it go a little quicker when you're by yourself, kind of going through and checking. So now when I check 2, I do find that it equals 0, and that works. So that's a good check right there. So we know that when we input 2, that equaled 0. So now how can I use that to keep solving the problem? So this is what we were doing before rational root theorem from here. How do I use that 2 to keep going and keep solving? Yeah, we got it's 2, right? So I have a degree of 3. I know 1 is 2, so there's 2 more I'm looking for. And I'm not going to just keep scrolling, like, inputting those, because what Elisha told us earlier is I could have had 1 real and 2 imaginary. So if my 2 that are missing are imaginary, it's not going to come from this list. So how can I find those 2 remaining solutions? Kind of using what we did before. What do you think, Laura? Yeah, well, what were you thinking? I don't know. That would be kind of hard to tell if you had your imaginary solutions, right? No, because those could just be irrational. So you don't know if it's going to be rational or like irrational or just imaginary. So how can you find those 2 remaining solutions? What did we do before when we knew that 1 solution worked and it was good? Right before our rational root theorem, how did we keep solving the rest of them? Yeah, you did synthetic division. So I can divide either by that factor of x minus 2 with long division, or I always think synthetic kind of moves a little quicker, so I'm just going to do synthetic division. I'm going to do it up over here. So I'm going to do 2. So this is always step 1. So step 1 is your P over Q. Step 2 is kind of like find the one that works. And then your third step from here is to like set up your synthetic division or long division if that's your jam. I think synthetic can kind of move a little quicker, so I always kind of prefer that. So if I'm setting up synthetic division, what would my coefficients be? If I think about first with x cubed, that's my highest degree. I have a coefficient of 1. And then with x squared, what do we have? -4, what would come after that?
0.
Good job putting that 0 placeholder in since I have no x. And then lastly, 8. Alright, so going through your synthetic division, breaking down 1, multiplying it by 2, now adding -4 and 2, and then cycling back through. So multiplying by 2 to give you -4, adding the 0, and then lastly, we end up with a remainder of 0, which check, right? We already knew that it was a solution, so we were like, okay, I'm on the right track. I'm doing something, right? And what do 1, -2, and -4 tell us? What do those values tell us? 1, -2, and -4. What does that tell us to kind of keep solving from there? What do we think? What do we think?
This is not.
1, -2, and -4. How can that help us? What do you think, Eamon?
Say like x squared.
Yeah, x squared, then what's my next term? Uh-huh. Great job. So I know I have x squared minus 2x minus 4. And then now we have a quadratic that we're solving. So what's my first question when solving a quadratic? Can I do what here? Can we factor? Does something multiply to -4 and add to -2? No, right? Because what multiplies to -4? +2, -2, that would have to add up to 0. So what do I do if I can't factor? quadratic formula. Yes, so solving from here, you would have x equals negative b, which would end up being a positive 2, plus or minus the square root of b squared, which is 4, minus 4 times a, which is 1, times c, which is negative 4. All divided by 2a, which is just 2. Alright, so keep solving from here underneath your quadratic, with your quadratic formula underneath your square root. What are you noticing? What's underneath our square root become? You have 4, and then minus 4 times negative 4, which would just end up being, yeah, so that's 16, so 4 plus 16, which is 20. So you have the square root of 20 that you're simplifying. And how can you simplify the square root of 20? Yeah, 2 root 5. So this ends up being x equals 2 plus or minus 2 root 5, all divided by 2. Ooh, and should we just leave our solution just like that? What could I do with all those? What can I do with all those 2's? Divide them by 2, right? Simplify. So this would be x equals 1 plus or minus 1 root 5, or just root 5. And what was my other solution that I know? What was our other solution from the beginning? 2. So here, I had a degree of 3. And Alexa told us our possible scenarios, right? 3 real, and then 1 real, 2 imaginary. I end up having 3 real solutions here, right? 1 plus or minus root 5. Do I have an I here? No, that means I have 3 real solutions. But only 1 was kind of one of those rational numbers, like easy, nice, neat number. That's enough?
How do you get 1 plus minus root 5?
So yeah, we got 2 plus or minus 2 root 5 over 2. So we just divided each of the 2's by 2. You know, 2 over 2 would just become 1 for each of them. What other questions do you guys have? Alright, so do we see kind of that purpose behind that P over Q, that rational root theorem? Just getting us our starter values. Alright, so why don't you guys take a minute, jot our next problem down, and then why don't you guys start finding whatever those P over Q's might be, and see if you can find one solution that works, and then we'll kind of finish the problem out together. So take like those 2 minutes to see how far you can get. Alright guys, so let's bring it back together. So you found all your factors for P, which were for 30, right? You had 1, 30. So I kind of think about it like, if I'm writing them out, I always like to kind of do it like a rainbow in the sense of start with 1. So 1, 30, and then if it's even, be like, okay, 2 is going to be next, which means 2, 15, and then I see 3, 10, 5, 6. I'm kind of moving it. What about for Q? If Q is 1, that just means my only factor is 1. So my list for P over Q is going to be all this divided by 1, which is just itself back again. Now, what are we doing from here? We're plugging in values to see which will be solutions, which equals 0. Has anyone found one yet that works?
2.
2. So we found 2 works. So if you did not find 2 yet, plug in 2 and kind of just confirm to check. And what did we see? We check confirm 2 works. Yeah? Alright. So we did our P over Q. Notice at the beginning we had 5 terms. So we were like, no way, Jose, we're not factoring that. We did our P over Q. We plugged in 2. We found 2 works. Now what can we still do to find how many more solutions should I be looking for if I know 2 works? What do you think, Eamon? 3. My degree is 4. I should have 4 total. So I know I have 1 real that's already going, right? So maybe I have 2 real, 2 imaginary, or maybe I have 4 real that I'm looking for from here. So I find 2 works. What should I be thinking about doing next if I know 2 works? 2 works, so what are we thinking about next?
Divide by.
Yeah, so we can divide by, so Socrates was just saying we could divide by the factor of x minus 2. Or if we already know x equals 2, you could just do synthetic division with just 2. So if you just do synthetic division with 2, setting it up, you'd have 1, 1, negative 11, negative 5, and 30. And once again, if you like long division, just kind of do whatever is your favorite from there. But I think synthetic division moves a little quicker, so I'm just going to use that. Alright, so why don't you guys take a moment and kind of finish the synthetic division on your own. And let's see what you find. Alright, so we got our remainder with 0, which was a good check. And what do 1, 3, negative 5, and negative 15 tell us? There are coefficients, and that means from here, kind of what's our first one is our coefficient for what term? X cubed, great job. So I'm going to have 1x cubed plus 3x squared minus 5x minus 15. And what are we thinking about doing next here? What do we see? What do you see, Senna? Amazing. How do I know I need to do grouping? How many terms do we see? 4. We have 4 terms. So you're still doing the process here of asking yourself, can we factor, right? And I don't know. If I can factor, I'm going to factor because that's going to give me my solutions probably a little more easily than what would I do if I can't factor? What would you have done right here if you can't factor? What do you think, Talia? Ooh, but it's x cubed. So what would we have done at this step here if I can't factor? Noticing I can because these x plus 3s are matching up. Let's say, what would I do here to keep solving if you can't factor? You're going to kind of hate this answer, but what would you do again? You do the whole P over Q thing again. Because if you can't, right, it's at cubic. We can't factor, so you do the whole thing again, unless if it was like what Talia mentioned, if this was just 3x squared as my leading term, then I could do quadratic formula. But since this was cubed here, then you'd like do the whole cycle over again. So, but lucky for us, we can factor, and we find our factors to be x squared minus 5 and x plus 3. And I'm going to set each factor equal to what to solve? What do you think, Damon? Great job. So I know I'm going to have x plus 3 equals 0. And we'll have x squared minus 5 equals 0. So x plus 3 equals 0. Easy does it. What do you know x would equal? Negative 3. What about x squared minus 5 equaling 0? What would that equal, Eamon? Great job. So x would equal plus or minus root 5. And think about that's going to give us, you add your 5 over, and then it's x squared. So you're taking the square root, and every time you physically write in a square root to solve, you must include your plus or minus. So here that gives us two solutions. Here's -3, another one. And I knew all the way up here we found 2, so that gives us our 4 solutions total. So we had our degree of 4. Kind of cool, so many things are coming together for us today, right? We added on with this new idea of Q over Q. We figured this out last week. You could kind of plug in values to find your solutions. We learned synthetic division last week and long division, and then kind of we've been doing factoring like from day 1 to help us keep solving from there. So lots of things coming together here. What questions do you guys have from today? All right, so I'm going to give you guys a couple of problems to try on your own. And, well, did we have any? Okay, yeah. We'll try these two, and then if you're up for a challenge, we'll end the class with a challenge and or homework time.